Hello again, AP Psychology. So by this point, you should have practiced on the statistics assignment. I would like you to take the time to really do your best on each one of these questions based on what you can understand. If you are to a point where you need to come in and just hear how to handle one, so maybe you continue on in the future, that is also fine. But it is really important that you go through that mental task of working through this on your own and not just going through the answers, so that we make sure that you're fully prepared, and as these later questions, that you really understand what these numbers mean. So the first step comes to calculating your mean, median, and mode. So these are just like they will in the AP exam, where you're given a simple set of numbers that you can hopefully do some mental math for, and at that point, then you will be able to create the basic calculations. So what you should have done for calculating the mean is you add all of those numbers together, and then you'll divide by 8. So in this case, your total should have been 32. You divide that by 8, you end up with a mean of 4. Your median, on the other hand, the best way to usually find that one is, sorry, I'm going to get my drawing screen up here. Best way to do that is to just scratch out numbers. I'm going to scratch out the high number, then I'm going to scratch out the lowest number, and I can repeat that process. Now the high number is 5 and the low number is still 2. Now the high number is 4 and the number is 2, and now all I have left are 3's. And so generally that's the easiest way to find the median. The mode, you just look at which ones occur the most. And although I X'd out all of those, when we clear all that out of the way, we can see that we have 3 occurrences of the number 2. And so that becomes the most commonly occurring number. To find the range, you should have just taken the biggest number, subtracted the littlest number. So that's 11 minus 2, which should end up with 9. So if you struggled on that first one, now you know how to do it. If you need to pause to work on the second one, please do so before we move on. So now we calculate a new set of numbers. So on the new set of numbers, once again, we add them together. We end up with 48. We divide that by, no, I'm sorry, I'm messing up my numbers. Yeah, we have 48. We divide that by 8. We end up with a mean of 6. Median, we can run through that same process once again. We take our big number, we take out a small number. We take out a big number and a small number until we end up with an anomaly, where now, and I say anomaly, it's really a more natural type of occurrence. So what number lies in the middle when I get down to a 4 and a 5? And it's actually that simple. The number that lies in the middle of 4 and 5 is 4.5. So we just do our basic math to cover that one. Then we get into our mode, and once again, we look at this and the numbers don't fit quite the same way they did the first time. So it is very common for numbers to be multimodal. And in this case, we have 3 different modes because we see the number 10, and we see the number 5, and we see the number 4. So this is a trimodal set of scores. And so all of those must be included for the right answer. Range is the same. We take our 10 as our biggest number. We subtract 3 out of it. We end up with 7. So hopefully that one was relatively straightforward for us. As we keep going, we hit our next question. Sorry, I was just... Sorry for the weird clicking that's going on there. I think we should be good again. So what we now see in our next question is it requires us to understand these normal distributions. So now our test has a mean of 80. So when we take our normal curve, we know the mean is 80. So let's go ahead and put that right there on the screen. Let's get a color that stands out a little bit more. So we know that center line represents 80. So when the center line represents 80, and now it tells us that the standard deviation equals 4. So that means each time we see one of these lines, we're either going to add 4 or subtract 4. So we add 4, we add 4, we add 4, and on this side, we subtract 4. So what we should end up with here is, if you are on the standard deviation of +1, your score is an 84. If you're on the standard deviation of +2, your score is an 88. And on the same thing, by subtracting, we get to 76, and then we get to 72. So now it asks you, so 68% of the students scored between, and what we're trying to get to is, we know 68% on a normal distribution falls between plus and minus 1 standard deviation. So we can see that right here if that was something that you were tripped up on. So that 68% is telling us, well, who falls between one standard deviation. So in that case, one standard deviation, we have -1 is 76, +1 is 84. So that first answer of 68% earned scores between 76 and 84. The next one, now hopefully that clicks. So the next one, our 95% fall between plus and -2 standard deviations. So this time we're looking at our 2 standard deviation. And in this case, it was 72 and 88 are the 95% of scores fell between those 2 scores. So then we get to the z-score of 1, and now we've already established that one. So your z-score of 1 is just that line where it says 1 SD, 1 standard deviation. So that's that same of 84. And then your friend earned a z-score of 1.5. So now we are falling right here halfway between +1 and +2. So halfway in between, we're only going up 2 points. So that person is going to be right there getting an 86. As we move on, let's go ahead and go to a new screen. So as we go to question 5 on your page, we now have a test given 400 students. The results are a normal curve. Good, that means our rules that we see on the screen apply. So the mean is 75. So once again, let's put a 75 right on there. And it tells us the standard deviation is 5. So I know I'm going to go +5, -5, +5, -5. And I can do that as much as I need to. So how many students received a score of 80 or better? So the first thing I need to now figure out is, where does the score of 80 fall? And so 75 + 5 = 80. So here's our magic score, is right on this line of +1 standard deviation. So now we need to figure out, well, how many students received that score or better? And in this case, what I recommend doing is trying to break the math down where it's the most easy. And there's multiple ways to come to the correct answer here. But the way that I would recommend that we do it is we take a look and say, so we know this line is half the scores. So that's always your 50% line. And so you can go and add all these tiny little percentages up, but it's kind of a pain. So the easier way to do that is just say, well, we know everything on this side of the line is half of the test score. So we can just take that and know that that's 50% of them. So then we also know that the next one up is 34%. So what we can now say is 80 + 34 would mean that on one side of 80, this is now 84%. So 84% of the student body received 80% or lower. So that means we can subtract 84 from 100, and that means that 16% are what's left on this side. So, and all we're doing is just process of elimination here. We're cutting out that last half, which makes this easier to do than calculating 13.6 plus 2.1 plus those tiny little percentages down there that are going to ultimately end up with roughly 16. So 16 is not quite your answer because this represents 100 students and it tells you that there are 400 students. So since there are 400 students, we go 16 times 4, and I'm going to make sure I'm giving you the correct answer, which is 64. So your correct answer here should be 64 as you take that 16 and we add those extra 4, as in the 400 students is where that 4 came from, since we're dealing off a 100 scale here. As we keep going, now we get to the bowling team. And I'm going to go to a blank slide on this one because that can be a whole lot easier to do. Now we're asking you to run some basic calculations here. And we're going to have to set up a few of our normal distributions to make this make sense. So the first set of data that we have is that Elvis is our competitor. So let's set up a chart for Elvis. So what we know about Elvis is that he has, and we assume all these scores are normally distributed, so we know that his score, his average, is a 205. So with an average score of 205, he has a standard deviation of 5 points. So there's a 68% likelihood that he will bowl on this particular match from a 200 to a 210. There is a 95% likelihood that he will bowl from a 215 to a 195. So I'm going to use that and just leave those on there for right now. So we need to beat Elvis, who we know is going to score with a 95% certainty. And if you're wondering where I got that 95, again, I just did 2 standard deviations. So 95.4% fall between plus and minus 2 standard deviations. So I just made 2 standard deviations, and we can say with 95% confidence that Elvis will score a 195 to a 215. So we got to look at the players that we could face up against Elvis. So next up, we have Sarah Bellum. So Sarah, we do the exact same process for Sarah. So Sarah, we know as an average of 180, which on the surface makes it seem like she's not that great of a bowler compared to Elvis. But what we can see here is Sarah has a much greater variance in her scores. So her standard deviation is 25 points. So again, if I go 2 standard deviations and say each one is 25 points, so we can say 180 plus 50, and I just skipped over to the plus 2 there to get to 50, 25 plus 25, means that she could get a 230. Now, on the other hand, she could have one of her lower days, and she could end up with a 130, and I just subtracted 50 from our 2 standard deviations. So Sarah has a 95% chance of bowling between a 130 and a 230. So next, let's switch up our colors and let's talk about, who is it? Heuristic. So Hugh, same process. His mean median mode is at 190, and he's a very consistent bowler. So his standard deviation is only 3. So that means his lowest score that we would reasonably expect him to get would be a 184. And again, that's a 3 for standard deviation 1 and a 3 for standard deviation 2. And we do the same thing up. The highest score we could expect him to get would be a 196. So we take a look at, I'm sorry, that's Hugh. He has a 95% likelihood of scoring a 190 to a 196. So good for him for being consistent. So now we need to make our decision. We know we're facing Elvis. Hugh has a 95% chance of scoring a 190 to a 196. And we see that does not really make him competitive against Elvis. So there's a small chance that Elvis could be bowling on his low end and Hugh could be bowling on his high end and he could beat him. But that's pretty small. Sarah has such wild inconsistency that she still has a pretty good chance of hitting in that same range that Elvis does. And so Sarah needs to be our correct choice because there's a 95% chance that she's going to, there's a chance that she is able to bowl in there because of the 95% chance that she's in that 100-point range. So it's not a guaranteed win by any means, but Sarah at least has a chance, whereas Hugh's chances are very, very small to be able to be successful here. Our last question that we dealt with here, and we're just going to go back to a blank screen here, goes back to whose data do we trust? We have Dr. Cloud, who has a P-score of 0.04. So when that presents, that should say, oh yes, that means that one variable causes the other, because that's what these tell us. So then Dr. Rain comes in with a P-score of 0.08. Now that means it's not statistically significant. That means that there is a 8% chance that the change happened because of chance. So we come down to which one do we trust more? And this is just do we understand where statistical significance is coming from and what it means? when you have two different studies, you have to default to the one that has more people studied. Because remember, the more people there are, the lower the chance that one of those little individual characteristics is going to mess up your data. So we always have to go for, when we have a study of 100 people versus a study of 800 people, the study of 800 is more likely to present valid results. And so based only on the information on the screen, we should have selected that no, we should not start drinking soda when we study, because when we go to the statistical significance, Dr. Rain, her study is more valid because it has more people, and therefore we rely more on that p-score of 0.08 than on the p-score that only was calculated from 100 people. So there's no math involved on this one. It's the recognition that more people makes a study more valid. So I went through these pretty quick. Feel free to pause, rewind, go back over, give it another shot if you need to. If you are still feeling like you are struggling with some of these or need me to walk through personally with you, feel free to let me know that. I am happy to help and want to make sure that we understand the logic behind all of these statistical analyses that we do in AP Psychology. So as always, reach out if I can continue to support you in any way, and I will see you soon.